Yeah, g'day, it's Charlie ZL2CTM. Well, I'm very conscious that I haven't put up a video for quite some time, so I thought I'd just do a quick update today just to have a bit of a chat about what I've been playing around with and I guess some thoughts and ideas for what I'd like to do sort of moving forward. Because I wouldn't mind doing another series of videos just to sort of encourage others to give homebrew a go, which is what I've been saying all along. Anyway, so I haven't been doing nothing over the last few months. What I have been playing around with are a number of antenna tuners, so playing around with the analog ones, with the Pi network, which has been quite interesting. I didn't think it sort of warranted putting a video up, so I've just been sort of playing around with that at home, which went really well actually. I was quite happy with that. Quite a large one. It used an old scrapped rotary variable inductor, which was quite a large one out of a, like I say, out of a variable inductor, which was good, so that was quite fun. Have also been playing a bit around with digitizing an old crystal channelized transceiver, an HF transceiver, like I say, had 6 preset channels. I elected to do away with that and to install a digital VFO. Based around, funny old thing, the SI5351, which worked well. This was just a matter of sort of working out the right levels to essentially bypass and to emulate the crystal oscillator. And that went particularly well. So that covered 3 bands, so all of 80, 40, and a little bit of 20. So that was quite good. And the other thing which has been quite interesting is playing around with fox hunting antennas. It's something I haven't actually done before, and it's something which our local ham club here is doing once a month, which I'm certainly enjoying. So I thought I'd sort of start the bottom end and work my way up. Later on, when I talk about sort of future ideas, I'll talk about what I'd like to do later on. But what I have been playing around with here is the differential time of arrival, the TDOA, the time differential of arrival type antenna, where you switch the antenna at a certain rate, at a audio rate. For example, I elected to choose 700 Hertz. And when the fox is not directly abeam the antenna, you start to induce the 700 Hertz tone. And it's essentially a matter of moving the antenna to that tone nulls out. And it's either behind you or in front of you. So you do have that sort of ambiguity. Typically, you would make that antenna, and I didn't put a video up because there's nothing startling about this. There's tons of examples on the internet. Typically, you'd use a 555. Incidentally, I don't actually have the particular one that I wanted, so I did have a whole lot of Arduinos lying around, so decided to smash the little nut with a sledgehammer and use an Arduino. That was quite interesting. So that's a 5-volt device, and that's just switching these two. In fact, I'll just zoom up on that because this was actually quite interesting in the end. Switches two 1N4148 diodes here, so they switch the two antennas at a 700 Hertz rate out the coupling capacitor to the receiver. Initially, when I built this, I wasn't getting a good tone, and as it turned out, I wasn't turning these diodes on hard enough for the 5-volt signal. So I basically just went back to the spec sheet and double checked what the average current is for the 4148, which is about 150 milliamps, and then elected to drop the two current limiting resistors here down to, I decided to choose on 47 ohms just to give it a little bit of headroom, and that fixed the problem. So that's certainly turning these diodes on a lot harder than they were, and I'm getting a much better, or a much lower impedance path between the two antennas and the antenna. So that's working really well. It also allowed me to have a play with, which I haven't used before, which was quite interesting, was one of these. In fact, there's another one here, 18650. So the typical sort of cell you see out of the likes of old laptop batteries and that, battery cells. This is a board that has both a battery charger built in, as well as a means of providing both 3 volts and 5 volts over several outputs. And this has worked out really well. It allows me to charge it up on the board, so I can charge up here, and then I can get that 5 volts output to drive the Arduino directly. So that's been quite good. It looks a bit gas or sort of tie-wrapped on, but the whole idea of this antenna was just more exposure to me and to sort of learn about how this works and have a bit of a play with, like I say, this 18650 board. So that's been a whole lot of fun. What I do want to do, and I might as well talk about it now, I do want to work out from first principles a Doppler DF antenna. So probably the 4 or 5 antennas being electrically switched around to work out the Doppler frequency to then work out whereabouts the fox is. What I would like to do is use one of the tensees. I've got a couple of tensees lying around. In fact, I've got 2 of these and one of these that I've had for several years now for various projects. And I think I've mentioned it before on the previous video that the maker of the tensee, he has provided a very, very good digital, a DSP, digital signal processing library that goes with this. Really, really good, and you can do some really interesting things. And yeah, some years ago, I think I put some videos up just playing around with a simple software-defined radio which use that particular library. Anyway, suffice to say that I want to use that same library and the FFT functions and the like to build from first principles a Doppler DFing antenna, which would be quite fun. Another thing that I want to play around with are these ADF 4351 development boards. Got a couple of different varieties here which I had posted across. I have not played with these boards before. They look quite interesting. They go from 35, if I recall, megahertz up to about 4.4 gigs. Again, don't know a whole lot about them, but I'm certainly quite keen to have a play with those and see if I can make a radio around that. Not quite sure what it'd be for the Doppler, but certainly for an SSB rig or something. So that's something else which I definitely want to play around with over the next few months. Other than that, what else are we doing? In fact, I'll just move this aside. The project is a... let me just move that. Just, excuse me. Is this here. So what I have been playing around with is a... Let me turn that light off. I think we've got enough light here. It's a DFing receiver that they're using for amateur radio emergency communications. It's looking a bit gash here because it's purely just a work in progress and something to play around with. It's up in the high VHF range, so it's an area which I haven't played with before. And I'm going to pause right here and make a big shout out to Rob. This is Rob's business card here. He is the New Zealand Siglent rep that has spent a lot of time with me, which is fantastic. So talking me through some of the Siglent range of test equipment to sort of help out. And thanks to him, I've actually expanded now my test equipment range. So I've now got a nice SIG gen from 9 kilohertz up to 2.1 gigs, as well as a 350 megahertz scope. So thank you very much to Siglent and to Rob for sort of providing some help and support there. So much appreciated. Like I say, I think I mentioned in the previous video, I've been using the Siglent for a little while now, and I've been really more than happy for what I do here. The range of equipment has been spot on. So anyway, for those in New Zealand, if you are interested, give Rob a call, and you'll certainly get some excellent support like I have. So thanks, Rob. Anyway, back to this. The test equipment's been really good because I've had to play around with frequencies which I haven't played around with before, and playing around with some of these pre-built development boards just to have a bit of a play and see how it works. So it's set around a single conversion topology. Again, right or wrong, just using the SI5351 to generate both the VFO and the beat frequency oscillator. The VFO, because of the high VHF range, I'm frequency doubling that, amplifying it, and then putting it through a discrete filter over here. which is another thing which I haven't played around with before. So if I can just make a bit of room here. So, apologies for all the movements. So using, if I can just zoom up there, some lumped components to build a little bandpass filter to just pick up on that second harmonic coming out of the frequency doubler. And that has actually been working really well. At the moment it's using a gimmick capacitor to link the two parts of the bandpass filter. So that's working really well. Another one over the back there for the incoming RF. So same thing again, slightly different frequency, but the same type of setup for that. What else? Simple little crystal filter there. So narrow band, just picking up on the transmission that I want. It's an on-off transmission, so just a simple little 500 Hertz crystal filter there, which I've covered before in the past. I have not at this stage made this into a video series. I won't because of the nature of what it is. However, I may look to build another one of these up into, say, the 70 centimeter range, which we can cover off. The other interesting thing which has been using for the frequency input is these little rocker switches here, or BCD encoders. I haven't used these before, and I thought this would be a good project to do it with. So if I just look at this one segment here, the way it particularly works is if I select, for example, say 6, out the back here we've got, oh gosh, way off camera, sorry about that. We have 4 outputs plus a common earth, and it's BCD, so it's 1, 2, 4, 8. So to get a 7, I'd need a 4 and a 3 and a 2. So when you select 7 on the front, like that, then the 1, the 2 and the 4, so 4 plus 2 plus 1 equals 7, they would all be grounded. And then what I've done, it was exactly which is down here, is just having the microcontroller multiplexing, looking across all of those and then determining what the number for each one is, and then stitching them together to come up with an overall frequency or the desired frequency of operation. So that's been quite a nice way of actually having a nice simple way of entering the frequency, but at the same time getting a feedback to the user on what the selected frequency is. So first time I've used those, and they work really well. Just sort of simple 4001 diodes here to basically allow that multiplexing and not have one interfere with the other one when its earth is being switched on to be read through these 4 parallel lines here. Anyway, that's been quite fun. What else? So in terms of future builds, what I like I've just mentioned before, what I would like to do is I wouldn't mind building another SSB rig, and what I did some time ago, and I wouldn't mind doing a bit of a deeper dive into it, is to build a 40 meter SSB rig using the NE612. So having that for both that particular device there has 2 inputs. So on transmit using one of the inputs, then on receive using the other input as a way of bands, or not band steering, that's one way of putting it, one way of steering, say, the IF stage between both the transmit and the receive. So I wouldn't mind revisiting that. Wouldn't mind doing 40 meters to allow the operation of around 70-90 kilohertz, which is the PODA and the SODA sort of watering holes here in New Zealand. Like I mentioned before, definitely want to do a Doppler DF antenna, and like I say, using the TNC and the DSP library that comes along with that. I reckon that'd be a really fun project, and something I have not played with at all before, so that would be certainly a quite a steep learning curve. There is another type of antenna which I have not played with. So I just mentioned before with the with that TDOA antenna, that you have the ambiguity that the transmitter could be either here or here. There is another version around there which, as each antenna is switched on, that the receiver, you basically sample the received signal and then compare it with the other antenna when it's switched through, and then you can work out the phase difference between the two to resolve that ambiguity. It's something I haven't played with before, so I'm just debating if I want to do that as a stepping stone through to a full-on Doppler. So that's something else I'm sort of thinking about. And as I just mentioned before, I do want to have a play with one of these development boards for the ADF 4351. Not quite sure what project that may go into. I don't know if we'd want to go into the 40 meter rig, because if I do that, then potentially I could use this for the VFO and then have a simple crystal oscillator for the beat frequency oscillator being fixed. We shall see, but either way, at some point in time I want to have a play around with these and learn how to drive them and see how they work. Other than that, I think by way of a catch-up, that's probably about all. Again, apologies for not putting anything up until now, but life gets busy and I've been playing around doing things, and like I say, I just didn't feel that what I was doing was either suitable or appropriate to put up. Anyway, moving forward I certainly will. Anyway, I will say 73, more than welcome for any comments or ideas and thoughts, and I will see you once I start that next project. Okay, cheers all.